Okay, Assalamualaikum, salam sejahtera. Okay, so for this week's lesson, it will be about non-parametric tests. Okay, alright. Seperti yang saya telah terangkan minggu lepas, parametric test ialah inferential statistical test yang kita buat dalam keadaan, dia kata kat sini, data is normally distributed and data is shows homogeneity and variance. Okay. For non-parametric test, lazimnya dibuat if your data is not normally distributed and there are the inhomogeneity of variance, and you use data that are in ordinal rank scale. Okay. Alright. Setiap satu non-parametric test ni boleh kata adalah cerminan ataupun reflection of the parametric test. Okay, for correlation tests, if your data is normal, you do Pearson, and if it's not normal, we do Spearman. Okay, kita dapat that analysis minggu lepas. Okay, so this is correlation. Now to find association, parametric tak ada. Non-parametric, chi-square. So association ni misalnya kalau kita nak tengok antara male and female groups dan juga tendency to eat an apple a day. So you have males, females versus tendency to eat apple, yes or no. Okay, tendency to eat apples ataupun how much student consume apples within a week. It can be one time, it can be 2 times, it can be up to 3 times. Okay, usually that type of data we do the chi-square tests, right? As for the independent t-test, we are comparing means between two groups. If some way somehow your data is not normally distributed, your alternative will be to do the Mann-Whitney-U test. Okay. It is for not normally distributed data, but it's not actually comparison of means between group. For Mann-Whitney-U, you are actually comparing median, and what it means is when you use median, you will have to rank your data from the high, if I'm not mistaken, highest to lowest to get the median value, and from there you will do the calculation to get the U statistics, and then compare with the critical value to determine whether there is a significance or not significance. Okay, you'll see the example in the video after this. Same can be said for paired t-tests. If your data is not normally distributed, you will do a Wilcoxon's test instead. Principle is same as Mann-Whitney-U. It's not actually comparison of means, which one is high, which one is low. It's actually a comparison of median, median of your data. Okay, and what I can say is to find the appropriate value, we will need to see how much we will rank the data and see how much are the positive increase versus the negative increase, and then from those values we will determine comparing to the critical value whether there is a significance or not significant difference, right? And then lastly, for one-way ANOVA, data is not normally distributed, you will be doing a Kruskal-Wallis H test, right? Okay, this is how a Mann-Whitney-U is. Okay, all right. This is how Mann-Whitney-U analysis is done. Okay. So first kita akan state the null hypothesis and of course the alternate hypothesis lah. Okay. So start following the style of parametric. The null hypothesis is usually we predict there is no difference between mean A and mean B, but perhatikan the words yang berbeza sikit dalam bandwidth AU is this word, median. Okay. Meaning we predict that the median score of smoker in group 1 is equal to the median score of non-smokers. Okay. In other words, you juga tulis, okay, there is no significant difference between the median score of smokers versus non-smokers. Whereas the hypothesis sama juga. We predict there is a significant difference ataupun contoh lain kata the median agak APG agak one mean score of smokers is not equals to the mean score of non-smokers, meaning there will be a significant difference in the median between group A and group B, right? Okay, if it's too technical, sebab ada median and tiba-tiba mean score, guna prinsip ni sajalah saya beritahu, right? For non-parametric, cerita macam ni saja. HO regardless whatever scenario, dinyatakan there is no difference in the median between group A versus group B. So another way to write this is if your HO will be there is no significant difference in terms of median between smokers and non-smokers. Okay, whereas for your HA, you can write saying that you predict there is a significant median difference between group A and juga group B. Right? Okay. Now let's see how calculation is done for this test. Okay. This is how it's been done in SPSS. We will hands-on this on Tuesday. Okay. Sama juga macam t-test. You can declare what are the groups. Okay. Alright, so this is the output yang akan keluar. So maklumat yang paling critical is the assumption for the two-tail. And kalau kita tengok kat sini, it's SPSS has calculated that it's more than 0.05, 2.16. So automatically, there is no significant difference lah. Okay, but okay. Once we've identified that, we look at the other values. So yang kita nak tengok sini adalah the bandwidth U score dan juga Z statistics. Okay. Alright. Now, how do we come to the conclusion of the assumption of the two-tail p-value is this is how it works. Okay, the U-stat formula uses this formula. The rank sum minus n dalam kurungan n tambah 1 bagi 2. Okay. Rank sum kita dapat through this table. Okay. Sum of rank. Ini kita kena ambil no dan juga yes. Okay. And then okay, how is this calculation being done? Saya ulang. Use statistics berbeza dengan mean score, bukannya kita ambil differences bagi standard error. Kita kena ambil rank sum jumlah jumlah keseluruhan ranking, and then tolak jumlah n darab n tambah 1 bahagi 2. Okay. So look at my screen on the right. Saya dah masukkan ke sini. Kita nak calculate how much is the use stat for yes and berapa use stat for no. Okay, not sure. Okay, this is the formula and this is how it's going to be calculated. Okay. Alright, for use statistic for yes, kita tengok di mana. 316.50 kita ambil di sini, column sums of ranks. And then the n, kita dapat 20 through di sini. Alright, and kita masukkan dalam kurungan tambah 1. And by right, when you do the calculation, kita akan dapat 106.5. Okay, for the second group, use statistic for no, 278.5. Kita tengok kolom sini, for no. And then 14 is the n value kat sini. So we do the calculations and we get the value here. All right. So next, we need to determine which one is the lowest of the two value. Okay. So 106.5 versus no. By right, the use statistic for yes is the one we use lah. Okay. This is one we are going to use. All right. Okay, next, how do we determine the critical value? All right. So for use statistics, kita kena tengok N1 ada berapa subjects and N2 berapa subjek. Okay. So once we look at this table, N1 kita ialah 14, sorry, ialah 20, kemudian N2 kita ialah 14. Okay, this column. So that's how the critical value of 83 is achieved. Okay, since we determine our critical value use stats is 83, now we need to compare. Calculated use stats lowest group versus critical value. Okay, now we compare the use stats that we calculated from the lowest among the two groups versus the critical value based on the distribution table. Okay, so in this case, the lowest one is from yes, kita ambil 1065 versus 83. 83 ada di sini. Ingat, how do we determine this? N1 is 20 and 2 is 14. Okay. Nilai N1 dan juga nilai N2. Kita dapat dah nilai sini. Alright. Berbeza dengan t-test, if our calculated t statistic is higher than the critical value, we conclude that there is a significant difference. Men with NIU terbalik. Okay, if our critical value is higher than 0, means there is no significant difference. Okay, this is the major difference between t-test dan juga men with NIU. Okay, if the calculated use test, I repeat, if the calculated use test is higher than critical value, there is no significant difference. The only instance where there is a significant difference if the U stats is lower than critical value. Only then you can conclude that there is a significant difference. Okay. All right. So this is a simple calculation because we already got the sum of rank value. Okay. But get this value steps dia agak fairly long. Okay. But I will show you through the video on how this the sum of rank value can be achieved. Okay, yang tu berada dalam extra notes manual calculation. Sekejap saya buka link dia untuk you tengok. Okay, let's see the calculation how it's being done.
This is Eugene O'Loughlin, lecturing computing at the National College of Ireland, and welcome to my series of short how-to videos. In this video, we're going to learn how to perform the Mann-Whitney U-test, and we're going to learn how to do this by hand. So before we start, let's take a look at the data that we're going to use in this test. I've got the results of an experiment where I want to compare.
Sama saja macam saya terangkan sebelum ni, dia ada dua group A versus group B, and dia adalah nilai data dia lah, the scoring.
Two treatments, treatment A and treatment B. And these are scores or ratings for by 6 people for treatment A and ratings by 6 people for treatment B. This tells us that this is an unpaired or independent t-test, as we have two groups being tested based on that the treatments are not the same.
Okay, perhatikan cara mana dia report hypothesis. Okay, saya rasa contoh ni lebih mesra alam. Tengok dia kata there is no difference between the rank of each treatment and there is a difference between the ranks of each treatment. Rank ni merujuk kepada median lah. Okay, there is a no difference between median of each group and there is a difference between median of each group. Okay, no difference. That is the keyword for null hypothesis or alternate hypothesis. There is a significant difference. Okay, no, dia tak guna perkataan mean dalam MEAN mean dalam Mann-Whitney U ni.
We're going to test here at an alpha value of 0.05, and we haven't indicated a direction for our test, so we're going to have a two-tailed test in this case here. So it's a two-tailed, unpaired or independent Mann-Whitney test. So as it is a rank-based test, I need to be able to rank all of these numbers, my 6 values for treatment.
To get the rank sum di sini, perhatikan this professor is going to rank the data from the lowest to highest. Okay, bukan highest to lowest, lowest to highest. If I said lowest, so highest to lowest before this, saya minta maaf. Okay, the correct way is to rank these numbers from the lowest to highest. Let's see how he did it.
A and my 6 values for treatment B. So that gives me a total of 12 numbers. So my first task is to rank each of these 12 values from 1 to 12. So
values, about we have 6 values here and 6 value in B.
So I'm going to write out just a series of numbers from 1 to 12 so that I can rank each of my individual values here. So now I'm going to rank all my values from the smallest to the largest value. So I'm going to look for the lowest value to rank it as number 1. I can see I have a 2 on my data, and I also have another 2. So I can rank my first 2 as number 1 and my second 2 as number 2. Now that gives us a tie, so we'll have to come back to that in a few moments. My next highest value is...
Kalau kata ada seri, perlu tengok semula.
3. So as I'm going along here, I'm going to tick off each of the values to indicate that I've scored them. Number 4 is my next highest value. And then when I come to the next highest value, which is a 5, so I've got a 5 in treatment A, and I've also got a 5 in treatment B. So I've got to put down 2 5s here, which is another tie. My next highest value is a 6 in treatment A, and there's also a 6 in treatment B. So I'm going to put down the 2 6s here for another tie. Then my next highest value is 7, which I'm going to rank as 9. After that, I've got an 8, which I'm going to rank as 10. I've got a 9, ranked as 11. And finally, I have a value of 10, which is my highest value, ranked at my...
Okay, so from the lowest to highest, okay, you can see that they ambil 2, 3, 4, 5, 6, 7, 8, 9, dan 10. Okay, where this value comes from? 2, 1 pada treatment A dan juga mana lagi? 2 kali sebenarnya. Okay. 3 pun 3 sekali, 4 ada 2 kali. Okay. This rank ni is from both data sets, okay, from the highest to lowest. Okay, now let's see macam mana kita nak distinguish bahagian yang ada seri ni lah. Okay.
At 12 in this case here. Now, before we do any calculations, we have to check for ties, and yes, we have some ties here. We have 2 2s, we have 2 5s, and we have 2 6s. So we need to be able to rank those. We can't use a ranking of 1 and 2 here.
Kita kena ubah ranking yang seri, dia kata.
Because we don't know which 2 it is. Okay, so for example, where we have 2 values of 5, 1 is in treatment A and 1 is in treatment B, so we need to rank those equally. So the way to do that is we just take the average of the rankings for, if we have 2 values, just add the 2 values together and divide by 2. So 1 plus 2 is 3, divided by 2 is 1.5. So my...
Okay, pastikan sini, bagi yang seri, kita ambil ranking yang atas ni 1 tambah 2 dapat 3 bahagi 2. So ranking untuk 2 ni ialah 1.
New rankings here are 1.5. Go down to my 2 5s, which are ranked 5 and 6. So 5 plus 6 is 11, divided by 2 is 5.5.
5.5.
My final rankings here, take the rankings 7 and 8 and add them together and divide by 2. So 7 and 8 is 15. So to divide that by 2 gives us rankings here of 7.5. So that's how we deal with ties. So now we...
Itu caranya, andai kata ada number yang seri lah. Kita tengok rank yang paling kecil, tambah dengan yang tinggi, bagi 2 kita dapatlah the rank for nilai yang seri ni.
We can see in our data, for example, here, we have nothing ranking as ranking number 1, and we have nothing ranking as ranking number 2, and so on. So now I want to take these rankings here, which I've just worked out, and put them beside each of the scores over here on our left-hand side. So, for example, in treatment A, the value of 3, we can see over here.
Okay, next, dia kata, apabila kita dah tentukan nilai ranking, kita tentukan, kita masukkan nilai ranking dalam setiap grup ni lah. Okay, kalau 3, nilai dia 3, 4 ialah 4. Kalau 2, nilai dia 1.5. Perhatikan.
That ranked as the 3rd highest value. The value of 4 ranked as the 4th highest value. Then it come to a 2, which was ranked as 1.5. Let's put that in there. And then come to 6, which was ranked as 7.5. 2 was ranked at 1.5 again. And 5, as we can see, was ranked at 5.5. Over to treatment B, we can see that 9 was ranked as 11. 7 was ranked as the 9th highest value. 5 was ranked at 5.5. 10 was ranked at 12. 6 was ranked at a 7.5, another one of our ties. And our final value, 8 here, was ranked as number 10. So now that we have all the...
Okay, perhatikan dia dah give the rank of each value based on this manual ranking system yang luar table ni. Okay, this is how the rank sum for treatment A and treatment B is being done. Okay.
Rankings here. Our next job then is to sum all of these ranks, because we need to get a value for our sum of each of these ranks. So I'm going to add up all the values for the treatment A, and when I add all of these up, I get a value of 23.0. And when I add up all the values for treatment B, I get a value of 55.0.
Okay, so saya ringkaskan. Cara nak menentukan nilai rank of sum seperti yang ada dalam ni, bawah ni, is basically to list up the data daripada paling tinggi dan paling rendah, dan rank dia daripada yang pertama hingga akhir. Andai kata ada value yang sama, kita ambil dua ranking, campurkan and bahagi 2, baru kita dapat average. Okay, that's why yang sini kita tengok 1.5 untuk nilai 2, 0.5 kita dapat 5.5 dan 5.5. Okay, and once you get this value, baru you isi the rank, some rank value sini, and you dapatlah nilai sum of rank for each groups. Okay, meaning saya pergi balik ke slide. To get this value, you would have to rank each of the 14 and 20 data dalam group masing-masing. Okay, if we do to do contoh tadi mudahlah sebab 6 in a group, but to do this it will be quite complicated and takes time. So SPSS dah tolong you calculate and dapat sum of rank di sini, but saya nak tunjuk ke sini to calculate the sum rank by hand. This is how it was done. Okay, you can rewind, relook at it multiple times sampai you faham, and then you cuba practice.
So these are my rank sum for each of the two values. Now I'm ready to actually do the calculation for the U statistic, which is what the Mann-Whitney U test is based on. My U statistic here, the formula, it's equal minus the number of variables in, and it's based on a U stat.
Okay, sama juga antara dua grup, yang mana rank SAM calculation yang paling rendah. In this case, it's UA lah, treatment A, and they come, and this step they can compare the critical value
is equal to 2.0. Next, I need to determine a critical value, which helps us accept or reject our null hypothesis. So I'm going to go to a critical values, the Mann-Whitney U test, and this is for two-tailed testing. And it's based on, I need the N1 for the number of values in group 1, that's treatment A in my case, which is 6. And I also need the number of values in group 2, which is treatment B, which is also 6 in this case. So if I just take the row and where the columns meet, so 6 and column 6 and row 6 here, we can see I have values for alpha equal to 0.05 and alpha equal to 0.01, and I'm choosing 0.05, and we can see there that the critical value is at.
So ini use test yang dia calculate between group A and group B. Dia pilih 2.0 sebab it's the lowest value, and then the U critical dia tengok buku sifir, dia dapat 5.0. Since U start lebih kecil pada U critical, dia simpulkan bahawa there is actually a significant difference. The HO is rejected while the HA is accepted, right? And that's how the full step of doing a Mann-Whitney U. Okay, untuk peringkat you all, untuk test dan final yang ni insyaAllah tak perlu buat lah. The sums means the sum of rank akan diberi terus. All you need to do is remember this part lah, the principle of finding the rank sum for group, the first group and the second group. Determine which one is lowest compared to the critical value, and then baru you boleh conclude whether there is a significant difference or not significant difference. Okay, so that's how Mann-Whitney U works. All right, now let's look at Wilcoxon's. Okay, let's see how Wilcoxon's science test is being done.
The National College of Ireland area was taken in August and in November.
Sama juga macam PRT test, dia akan ada set of data sets from a early former state to a later state. Okay, before intervention and after intervention. Okay.
Figures here represent the concentrations of aluminium in micrograms of aluminium. If that's the case, then we use the Wilcoxon signed rank test. So before this video, I've conducted a quick Shapiro-Wilk test on each of the August and November, and we must use a non-pair. Our null hypothesis is that the median difference between the pairs of observations is 0, and note that the
sama juga macam Mann-Whitney U, your HO, your null hypothesis, you predict there is no median difference between August and November ataupun before and after, while your alternate hypothesis, you predict that there is significant median difference. Okay, keyword sama macam Wilcox value bukan mean but median. Okay.
Hypothesis is based on the median.
Based on the median.
Our alternative hypothesis is that the median difference between pairs of observations is not zero. We're going to conduct our test. We have an alpha value of 0.05, and
right, saya cuba skip kepada this part, the rank.
Our next job then is to rank these
Okay, yang saya skip ialah macam mana dia dapat beza antara dua nilai ni. Okay, kita ambil contoh. August, Columbia River 18.3, November 12.7. So dia dapat a difference of negative 5.6, meaning from August to November ada penurunan. Dia negatif lah. Bagi yang ada peningkatan, mari kita tengok misalnya this one, Redford 9.5 naik ke 10.5, dia tulis sebagai 1 atau positif 1 lah. Okay. First column, what are the difference, positive or negative? Absolute difference is how much kesetaraannya. This column is for you to distinguish whether there is an increase or decrease value, and this is the absolute value. Okay, so that's why you tengok sini. The first three are negative, but bila datang sini kita declare it as positive. Alright. Okay, now how do we rank them?
Absolute values. This is why we need the absolute values, because we don't want to rank any negative values, but we want to rank all of them. And we're going to rank them from the smallest to the largest value. So reviewing this absolute difference column here, I note that my smallest value, which gets...
To determine the rank, kita bukan tengok the difference yang ada negatif atau positive sign ni. Kita kena tengok the absolute difference. Okay, tengok macam mana rank. Paling kecil dia jumpa is 0.1. So that is, oops, sorry. Okay.
From the smallest to the largest value. So reviewing this absolute difference column here, I note that my smallest value, which gets a rank of 1, is my value of 0.1. My next smallest value is the figure here beside it, 1.0, so I'm going to write that as a rank of number 2. And my third figure is 1.2. So as they are increasing, I'm adding in the ranks. The next highest figure is 2.0. That gets a ranking of 4. Okay. The next highest figure is, now you can see these are all sequential here at the end. So the last...
Sama juga macam bandwidth ni, we rank the values from the lowest to highest. Okay.
Sets of rankings are easy to determine here. So just to recap here for a second, our differences, we are very, very important that we note the sign. This is a Wilcoxon signed rank test. So we need to know all the positives and we need to know all the negative differences. And then we need to know the ranks of all the positives and the ranks of all the negatives so that we can sum them. So we need to know the rank sum for the T pluses and for the T minuses.
Okay, so use stats, kita banding use stats for the first group and the second group. For Wilcoxons, we compare the absolute difference. Kita akan kumpulkan yang nilai negatif menurun dan juga positif. Okay. Dan yang ketiga, andai kata ada neutral value pun kita calculate juga sebenarnya. Okay, but in this instance, dia ada negatif dan positif saja.
Do that, I'm just going to use a highlighter here.
Okay.
So I need to highlight all of the negative values that are conveniently here at the top, and then select the ranks for each of those there. So these are all the negative values. So the rank sum of the negative ranks here is 8 plus 5 plus 3, which is 16. And then I'm going to do the same for all the positive values. So they're all conveniently here for me. So these are all the positive differences. And these are all the positive ranks. This is going to give me my T plus, all the positive ranks. So when I sum up all these values here, 1, 2, 4, plus 6, plus 7, and so on, I'm going to get a T value here, T plus value of 75. The Wilcoxon assigned rank test statistic is called W. So my W stat, what's the test statistic? Well, it is the smaller...
Okay, sama juga prinsip macam bandwidth ni. choose the smallest value between the two groups. In this case, positive, positive lagi banyak, negative lagi sikit. So the W stats is 16.
Of these two values here. So the W stat is 16.
Okay, now
just to check back for a second, if
nilai dalam buku sifil lah, which is the tak silap saya W distribution. Yang saya check. Okay, betul. So the N value is referring to how many pairs, berapa pasangan yang kita ada lah. So let's see what our professor punya critical value.
if any ranks are the same, so if you get two different absolute differences which are the same, you take an average of the ranks for those 2 or 3 ranks in that case. So now our test statistic has a value of 16. We now need to determine a critical value so that we can compare our test statistic with a critical value to determine if there is a significant difference. So to do that, I'm going to use a critical values of the Wilcoxon signed rank test table. And to check back here, right back at the beginning of the video, I stated that our alpha value was 0.05, that N was 13.
Okay, kita tengok nilai N, dikata N yang berapa test yang ada kat sini ialah 13. So 13 kat sini, dia and significant total 17.
And you can also see that we are doing a two-tailed test here, no direction, at a critical value of 17 hypothesis. We reject H0.
Wilcoxon's sign rank sama juga macam Man with NIU. If our calculated value is lower than our critical value, means there is a significant difference. Okay, if it's this value is higher than the critical value, then there is no difference lah. Okay, all right. So that's how Wilcoxon is being done. You can refer back to this video for further clarification. All right, so let's look at the third analysis, which is the counterpart for ANOVA, the Kruskal-Wallich H. We are comparison the median between 3 different groups. Okay, so cara reporting, cara null hypothesis dan alternate hypothesis diformulasikan sama saja. There is no difference, or we there is a significant difference distribution between the 3 different groups. Okay. Alright, so saya ringkaskan kat sini, sama macam Man with NIU dan Wilcoxon. We rank from the lowest, from the lowest to highest, and we will rank the data based on all 3 groups. Okay, so from here 8.2 ada kat sini, the prophylaxis is the lowest value, followed by 8.4, which is the second lowest value. 9.1 is third lowest value, but they muncul sebanyak 3 kali. Alright, so dia dah ambil average value rank sampailah value yang akhir sekali 17. Okay, sama macam Man with NIU, kita masuk setelah kita tentukan ranking, kita masukkan ranking ni based on the value yang ada pada setiap group lah. Okay, how does 8.2 dapat 1 sebab kita dah ranking dia kat sini. Alright. And bagi yang ada seri, misalnya 901 bukannya 3, 4, 5, 6, dia ambil purata, which is 4. So that's why sini ada 4, sini 4, ada lidah 902, dan sini pun 4. Okay, and the list goes on. And then the professor, the rank sum for the 3 groups, dia dah kira kat sini. So R1 is 43, R2 is 61, and R3 is 67.
Bit of the computing done. The next bit then is to put my values into my formula over here. So let's
formula for Kruskal-Wallich ialah yang dinyatakan di atas ni. Okay, so the sum values for 3 groups will be used here.
Write my formula out here. So the H statistic is equal to 12 divided by n, which I've already determined is 18, the number of values, multiplied by 18 plus 1. And then I'm going to add to that, multiply that by the sum of each of my three sets here. So R1.
So 12 bagi M is the total of how many respondents are there in this data set. Ada 18, so apa? 6 campur 6 campur 6, 18. Okay. 12 is the default value.
1 squared is going to be 43 squared divided by the number n in sample, the first sample, so that's going to be 6. And then I'm going to add that, because I'm summing here, don't forget, to R2, which is 61.
Okay. In this bracket, kita senaraikan R1, R2 dan R3. Masing-masing kita kuasa 2 kan, and bagi berapa bilangan n value dalam setiap group.
Squared, divide that by 6 again, because I've got 6 values in sample 2. And finally add that then to the sum for rank 3, which is 67 squared divided by 6. And we multiply that by minus 3 times 18 plus 1. Okay, so follow back through there if you're not sure where each of these values came from. And when I work all of that out, I get a result of 1.82.
So my based on this formulation, and dia dah masukkan nilai-nilai yang berkaitan, dia dapat H value for of 1.82. Okay, for non-parametric, ingat U stats for man with U, W stands for Wilcoxon, while H stands for Kruskal-Wallis H.
H stat is equal to 1.
So berbeza dengan man with U dan juga Wilcoxons, dia tak ada kita tengok U ataupun W value yang tinggi yang rendah. Dari statistik kita dah kira sekali harung, right?
H2. Before I can determine whether this is
dia nak tentukan critical value,
a significant value or not, I need to determine the degrees of freedom. So I'm going to abbreviate that as degrees of freedom, DF. And it's a very simple calculation for a Kruskal-Wallis test. As in a one-way ANOVA, it is the number of groups or number of samples minus 1. So I've got 3 groups here, so 3 minus 1 is...
Degree of freedom, dia kata senang saja, the amount of groups, tolak 1. So it's 3 minus 1
is equal to 2. So I've got 2 degrees of freedom. This allows me then to take a look and find the critical value for this. And the Kruskal-Wallis stat here follows a chi-squared distribution, so I'm going to use my chi-squared.
Okay, Prof kata kat sini, for Kruskal-Wallis, kita bukannya ada distribution for W ataupun U stats, tetapi kita tengok chi-square distribution table sebab Kruskal-Wallis ni menggunakan konsep chi-square untuk cari nilainya. So, chi-square distribution table to and significant at 0.5, it should be right here. Halus sangat. Saya baca sini 0.103. Let's see if I'm correct.
Tables here, and look across the degrees of freedom column here. So I've got 2 degrees of freedom. To look across that, and I'm testing at an alpha value of 0.05. So my chi-squared critical value in this instance here, it has a value of 5.991. So my chi-squared crit is equal to 5.991. I can see in this case here.
Okay, so use H stats, dia dapat 1.82, but based on the distribution table, the critical value is 5.991. Okay.
My H stat is less than my chi-squared.
So agak-agak significant atau tak?
Critical value. Therefore, I cannot reject HO. Here, I'm failing to reject the null hypothesis that the 3 probability.
Okay, Prof kata kat sini, memandangkan H test yang dikalkulate dengan tangan lebih rendah daripada critical value, means we do not reject the null hypothesis, we accept it. Okay, hanya man with NIU dan juga Wilcoxon's, nilai calculated value, whether it's the Wilcoxon or the U statistic, has to be lower than the critical value baru significant. However, for Kruskal-Wallis, if your calculated H-stat is lower than the critical value, you actually have a not significant difference. Meaning for H-stats, this value actually has to be higher than the critical value for you to reject null hypothesis and accept the alternate hypothesis and concluding there is a significant difference. So itu perbezaan ketara ya antara Mann-Whitney-U dan Mann-Whitney-U, Wilcoxon's versus H-stat. Sorry, Kruskal-Wallis. Kruskal-Wallis, H-stat perlu lebih tinggi pada critical value while the other two perlu lebih rendah. Itu perbezaan ketara. Okay. Alright. For the fourth analysis, kita tengok the chi-square test. Okay. Chi-square test is a non-parametric. Okay. Walaupun you dapat data yang normal, you tetap kena buat chi-square. You boleh buat chi-square test. Apatah lagi data you tak normal sebab dia punya main criteria for chi-square is categorical data. Okay. Dia bukannya apa, dia bukan numerical ataupun menggunakan Likert scale 1 hingga 5. Okay. Dia kena nominal 1, 2, 3, 1, 2 ataupun rank. Okay. Right. Test valuation, whether the different similarities respond, and berbeza dengan ANOVA t-test ataupun ANOVA t-test ataupun paired t-test, the concept of calculation for chi-square bukannya mean score ataupun median score. Chi-square ni dia punya hukum calculation dia is based on frequencies, the n value. Okay. Alright, so okay, ni antara contoh data yang sesuai untuk buat analisa chi-square lah. Okay, antaranya gender, ethnicity, HDN, BMI. Okay, how to ni adalah contoh how to recode lah sebab BMI ni is numerical, but if you want to do a chi-square for BMI, kita kena categorizekan lah. Okay. 25.8 macam contoh ni, more than 23. Okay. Okay, saya rasa saya tunjuk data set lah untuk dapat untuk beri gambaran how data macam mana yang sesuai untuk chi-square sekejap ya. Okay, so kesesuaian data untuk buat chi-square saya tunjuk beberapa ya. Okay, misalnya contoh gender, mana lagi, region, pelanggan tu daripada KL ke daripada Penang. Okay. How often do you eat nasi kandar? Mana dia? Okay, how often do you eat nasi kandar? This is categorical example of how categorical variable or data looks like. Dan apa lagi? Yes, no items. Okay, adakah anda makan nasi kandar waktu pagi, waktu tengah hari, waktu malam? Okay, categorical. And apa lagi? And lauk yang biasanya pilih apabila makan nasi kandar. Okay. Semuanya yes, no, yes, no. Okay, tak ada pun nilai 23.5 25.4, 25.6. Andai kata kita ada data macam tu, tak sesuai lah untuk kita buat chi-square. Right? Okay, how to perform the chi-square? Macam biasa saja, state the null and alternate hypothesis. Okay, the keywords for chi-square is bukan there is a significant difference or there is no significant difference. Contoh ayat macam mana? Contoh ayat macam ni. There is association between customers from different region towards nasi kandar consumption. So that is the alternate. If it's null hypothesis, you predict there is no association between customers of different region and their nasi kandar consumption. Okay, keyword di sini adalah association. Okay, bukan correlation. Chi-square keywords dia adalah association. Once you set the hypothesis, okay, set the significant level, macam biasa 0.05, check the assumption, do the data analysis, interpret, and conclude. Sama saja, right? Pastikan your data is categorical. Lagi sekali saya ingatkan, and cuba tengok macam contoh yang saya nyatakan tadi. Keywords here is association. Null hypothesis, no association between gender and eminent status ataupun gender and consumption pattern. If it's a HA, we predict there is ini curve. Ini keywords there for chi-square. Alright, the assumption. Right. Two variables are categorical. Right. Okay, to find sama juga macam non-parametric dan parametric test yang lain, kita kena cari our calculated value for in chi-square. Yang ni yang kita cari sebenarnya, okay? The chi-square value, and this is the formulation, okay? The chi-square distribution, right? This step kita akan lalui in kelas SPSS pada Selasa dan Khamis masing-masing, right? Okay, so saya akan tunjuk demonstrate on how chi-square test this formulation is done via hand. Okay, let's go back to Prof. Eugene's video. Okay, let's see how the hand calculation is being done.
Follows. So this is my symbol here, chi-squared. It's equal to the sum of our observed, difference between our observed and expected values, O minus E in here, squared, divided by E, our expected values.
It is observed minus expected value, kuasa 2, and bahagi expected value.
So as you can see, we need just two values to help us determine chi-squared. O for observed, which we get from these values up here, and E for expected, which we will determine in a moment. So before we start, let's outline our null and alternate hypothesis. So just putting in the not equals to sign 5 subs. And my observed values are simply the four values that I have up here. So I'm going to put in 441 hearts, 404 spades, 402 diamonds, and 353 clubs. So I can take away my question there now, give myself a bit of space. And next we have to put in our expected values. So that's going to be designated with an E.
So observed value kita dah ada kat sini berdasarkan nilai yang ini, heart, spades, diamonds and clubs. Okay. Okay, let's see the professor's calculation first and reflect back apa yang ada dalam extra note saya. Okay.
1,600 cards. We would expect each suit to occur 1,600 divided by 4, which is 400. So we would expect exactly the same number of cards to be determined if they're drawn at random. So each of these two rows here adds up to 1,600. So now we have the two values we need in our formula, so let's go ahead and work out the calculations. So first of all, let's do O minus E, and that's the difference between the observed and expected. You can do E minus O if you want, it doesn't matter which way you do it. So I'm going to do these first calculations in my head. 441 divided by 400. 600. So now we have the two values we need in our formula, so let's go ahead and work out the calculations. So first of all, let's do O minus E, and that's the difference between the observed and expected. You can do E minus O if you want, it doesn't matter which way you do it. So I'm going to do these first calculations in my head. 441 divided by 400.
So O minus E, this is something like a 2 by 2 table in chi-square calculation.
Take away 400 is 41. 404 minus 400 is 4. 402 minus 400 is 2. And 353 minus 400 is minus 47. Next, we can see in our formula that we need to square that value. So let's do O minus E squared. So I
need kita squarekan O minus E.
Need my calculator for that. So first of all, it's 2,209. The next part of the
O minus E 400 tolak 41, and then kita kuasa 2 kan, kita dapat dah. Okay. O minus E untuk yang speed 04 404 minus 484, and then kita kuasa 2 kan. Okay.
Calculation is we need to divide that number by the expected value. So for hearts, that's going to be 1,681 divided by 400. So let's write that in. O minus E squared divided by E. So work 1,000.
Perhatikan Prof buat ni step by step. Okay.
681 divided by 400 is 4.2 rounded. Next is 16 divided by 400 plus point.
Okay, to get the whole chi-square value, we take this value yang kat bawah ni and sum it up. 4.2, 0.04, 0.01 and 5.53. Dapat apa?
0.04 plus 0.01 plus 5.52 is equal to 9.77. So my calculation here, my chi-squared value is equal to 9.77. So that's what we've worked out in this formula up here.
Okay, now
we need to determine a critical value from our chi-squared distribution table. So we have a distribution, something like this, for chi-squared. Freedom is going to be the number of groups minus 1. So that's 4 minus 1, so that gives me 3. So 3 degrees of freedom. My alpha value, already worked that out at 0.05. So I'm now ready to look up my chi-squared distribution table, which is looks like this here. So I have right across the top, I can see what my probability is. So it's 0.05 I have chosen. And the row I get, it gives me the number of degrees of freedom. So where they intersect, a value of 7.81 occurs. So that's my critical value. So my critical value is equal to 7.81. So here I can write in 7.81. We can see that my chi-squared value exceeds that, so now it's time to report and make a decision. So we report like this: chi-squared for 3 degrees of freedom, it's equal to 9.77, and her probability was set at 0.05. So that's how we report our result. We can see here that our chi-squared value is greater than our critical value. So our chi-squared value is going to fall into the rejection region over here, 9.77. So therefore our decision is that we reject our null hypothesis.
Okay. Perhatikan chi-square, the calculated value lebih tinggi daripada critical value. Sama macam Kruskal-Wallis dan juga parametric test. Meaning if your calculated value is above your critical value, you conclude there is a significant difference. Number 2, reject null hypothesis and accept the alternate hypothesis. Okay.
So we're rejecting our null hypothesis that there's no difference between the observed and
That is actually
expected.
an association. Okay. So that is how chi-square is being done. Saya ulang balik. Parametric, semua parametric test, campur Kruskal-Wallis, campur chi-square, dia punya calculated value mesti lebih tinggi pada critical value untuk you kata significant difference, reject an hypothesis, accept alternate hypothesis. But if for men with NIU dan juga Wilcoxons, your value needs to be lower than the critical value. Kena lebih rendah baru significant. Okay, itu perbezaan ketaranya, right? Okay, so kita cuba compare apa yang Prof. Eugene tunjuk dengan apa yang ada dalam nota. Saya rasa sama saja. Okay. Establish hypothesis macam biasa. Number 2 is calculate the expected value for each cell in the table. Expected value, cara kita nak cari is total amount of row and total amount of column and bahagi n. How do we get that? Compare the percentage of male and females who prefer science course at a university. Okay. So formulation dia, amount of male times students who choose science-based course and then total amount of student sample. Okay. So asalnya, okay. Asalnya kita kena senaraikanlah our raw data. Biasanya how many males and females, science-based and non-science-based. First step is to total up how many males yang jawab suka dan tak suka. So we get 234, while as females pun we do the same, 74 plus 166 dapat 240. Okay. And then we tally up lah yang suka science base sebanyak 166 campur non-science 142 campur 166 dapat 308. 166 dapat campur 308 dapatlah 440 total respondents. Right? So the values yang ada dalam table ni ialah the observed variables. Yang kita nak cari dalam calculation di bawah ni is the expected values. Okay. Okay. To get the value for A11, A12, A21 dan juga A22, formula atas ni yang kita pakailah. Okay. Total amount of male, number of students science based and the number of students in this sample. Okay, for A11 total amount yang ambil 23 darab 166 di sini, and then jumlah sini adalah 2874. Okay. So A12 merujuk kepada male pula, tetapi yang ambil jurusan bukan sains. So dia ambil nilainya 234 darab 308 bagi jumlah keseluruhan. Okay. So okay, saya cuba annotate sikit. Alamak. Oops. Baik, padam pula. Ya. Okay, perhatikan anecdote yang saya buat kat sini. A12 dan juga A11. Ini adalah calculation bagi expected value bagi males yang ambil sains dan males yang tak ambil sains. Whereas A21 dan juga A22 ialah the expected value untuk females yang ambil sains dan yang tak ambil sains lah. So we get these expected values from these four groups. Okay. Okay. Once we get the expected value for each response, so this we put the value inside lah. For A11, A12, A21, and A22. And baru kita proceed to the calculated chi-square statistics. Alright. So four types of respondents. Male yang ambil science base, yang ambil non-science, female yang ambil science, and female who do not take science field. So we put in the observed values, 92, 142, 74, and 166 minus each of the expected count. Kita dah calculate sini. And untuk setiap satu grup ni, and cuma kita kena kuasa 2 kan. After all, this is known as a chi-square, and dah ada kat sini logo kuasa 2. Right? So if you do the hand calculation, you will get one. Saya ini dulu. Okay, the four formulations saya dah tolong categorizekan. Okay, the first one is the male the observed count, tolak expectancy counts, and bagi expectancy counts for the males yang science based. Second one, yang ni, it's for males who do not take science courses. The third one is for females who take science courses, and the second one is females who do not take science courses. Okay, therefore you get all this value, you add it up, you dapatlah 3.169. Okay, so we got our calculated chi-square is at 3.164. Alright, so let me sum up it here in this Word document. Okay, so based on the extra notes, calculated chi-square value is 3.16, and the critical value based on the buku Zifir here. My apologies for it being upside down. Let me see if I can rotate it. Since critical value-nya kita identify degree of freedom kita identify dia sebagai 1, mudah je lah. Look at line 1 and 0.15, that's where 3.841 comes. So saya tulis di sini, based on the sensitivity value, is 3.841. As 3.16 is lower than 3.841, sama juga macam apa yang Prof. Eugene kata tadi, means there is no significant difference. Null hypothesis is accepted. And we conclude there is no association between gender, right? Okay, and that is how chi-square calculation works. All right, so before I end up this recorded lecture, let me summarize you the key points with the assistance of ChatGPT. Okay, come, let's see what ChatGPT has helped in summarizing. One moment, let me open the browser. Okay, so let's see what Mr. ChatGPT has helped compile. So man with a U, alternative to independent t-tests is comparing medians of two groups. The Wilcoxons, alternative to the paired t-test, compare medians of two groups, repeated measures, meaning before and after. Kruskal-Wallis H is alternative to one way where we compare medians of 3 or more independent groups. And then what we have here is the chi-square test. Use category data to determine whether there is an association between two groups. And our friend from last week's practical class, the Spearman's rank, Spearman's correlation, the measure strength and direction relation between two ordinal variables. Okay. So Miss Man with me, Wilcoxon's, Kruskal-Wallis, chi-square dan Spearman, mereka ni adalah non-parametric ya. Alright. Okay, here's a summary of how manual hand calculation from when Man with me, Wilcoxon and Kruskal-Wallis is being done. This is all the steps that is needed. Okay, it is reflective in the videos and the notes that I've given you just now. Okay. For Man with me, you need to compare some ranks of the first and second group and choose the one that has the lowest sum rank and then compare it to the critical value from the Man with the U table, right? Sama juga untuk Wilcoxon test. Okay. Do the rank calculation. Cuma kita kena compute sum of positive and sum of negative. And then determine whether the negative or the positive is the smaller value, and then use that to compare the T statistic, or the W test statistics. And as for Kruskal-Wallis H, we rank in 3 groups and then compute the H statistics. Okay, and compare using a chi-square table. And here are the similarities of the 3 methods. Sebab dia menggunakan mean atau median atau rank. Okay. Obviously, they are non-parametric. They use rank system for the calculation, comparison of medians. Testing sama saja. Interpretation of results are either in U, T, or H. Okay. All right. These are the differences. Man with need 2 groups, 2 paired groups for Wilcoxons, and 3 or more independent groups for Kruskal-Wallis. And last kali, tengok saya tanya, is it true that man with U and Wilcoxons use stats needs to be lower, while Kruskal-Wallis and chi-square value needs to be higher? Our good friend Mr. JetGPT pun mengatakan benda yang sama. Tengok, man with U needs to be lower or equal to the critical value. Okay, U and T needs to be value. U and W, sorry. ChatGPT pun boleh buat salah. Alright. Why is the reason? Critical value for these tests are based on assumption of that rank. Alright. As for Kruskal-Wallis dan chi-square, sebab asas Kruskal-Wallis menggunakan konsep sama macam chi-square lah. Okay, and that's why Kruskal-Wallis and chi-square test, the value needs to be higher than the critical value for the result to be significant. Okay. And here's a summary of decisions that GPT has helped. Okay. U and W needs to be lower, H and chi-square needs to be higher. All right. Thank you very much, Mr. GPT. All right. So these are the fundamental concepts, and I've done my best to show you through video and notes that I've given you. All right. So the rest will be up to you to explore on your own. I've already given you the basic concepts. You may relook this video, rewind and replay this video as much as you can, reread and reread the notes as much as you can. But I highly encourage you to practice the manual calculation itself on your own, because I believe the original slides has some kind of small exercise. Okay. All right. So with that, I've come to the end of the recorded lecture. Even though it was quite hectic for me to get used to, because I've left using recorded lecture for quite a long time, but I've done my best to accommodate your condition. I understand it's very tiring to come back from a long stage, but I done my part to to give you explanation of how non-parametric has been done. Okay, all right. So with that, I end the lecture for today, and I hope we will be able to meet on Tuesday and Wednesday, Tuesday and Friday, and Thursday for our final lab session, which is non-parametric. Okay, it's pretty much straightforward than what you learned for today. Okay, all right. Thank you. Assalamualaikum warahmatullah.